Everybody, we're given a conditional equation here that's certainly not true in base 10. So we have to consider 664 base B. I use the subscript, I guess, base B. And it's clear that B cannot equal 10, right? B is not equal to 10. That's a fact based on the absurdity of the conditional equality there. So it's not base 10, right? B is not, definitely not base 10 because 664 is not equal to 5 times 125, right? So again, we're looking for another base right here. We're supposed to evaluate 5 factorial, which would be 120 if we were in base 10, okay? Now, let's just take a look at how we interpret this statement. Since B is not equal to 10, we have to find the value of B. And so I've just rewritten this conditional equality and rewritten 664 in terms of another base, okay? And it's all pretty straightforward. 6 times B squared plus 6 times B plus 4 over 5, okay, is equal to 125. Now, there's an understood 1 in front of this B squared, right? So there's a 1 times B squared right there. So you have the digits 1, 2, and 5 in some other base, okay? 125 in some other base. Now the rest of this is fairly straightforward. Notice that if we multiply through by 5 and subtract, okay? If we multiply through by 5 and subtract right here, okay, we get this statement here. Notice you would get 5b squared, subtract that from 6b squared, you just get 1b squared right here. Okay, right here you get 5 times 2b is 10b, subtract that from 6b and you get minus 4b right here. And of course right here if you do 5 times 5 you get 25, subtract that from 24 and you get minus 21. Okay, now you'll note that this piece right here does factor into b minus 7. B minus 7 times B minus 3. B plus 3, excuse me. Equals to 0. And we actually get 2 bases here. The negative base is a little unusual. I'm just going to work with the positive base. But anyway, that leads to these 2 values, B equals 7 and B is equal to negative 3, which is interesting all by itself. I'm just going to work with B is equal to 7. Okay, I think it's a little problematic to work with negative 3, but I think it does work out if you want to spend the time. Now we're supposed to evaluate 5 factorial up here. So 5 factorial is equal to 120. If you multiply those digits together in any base, it's equal to this. It's equal to 120 in base 10 for sure, right? But we know our base is now 7, right? And so what we're going to get right here is that 5 factorial, and you can do a little bit of mental math right here, but 5 factorial is equal to 120 base 10. I'll just write that down to avoid any ambiguity here. It's 120 base 10 for sure. So 5 factorial in base B, again, if you just do the math here, 7 squared is 49, 2 times 49 is 98, so 5 factorial is, again, it's 120 in base 10, but it's equal to 2 times 7 squared, and that's 98, all right? All right, and then so you still need it to add up to 20, or 120, right? So you would need plus 3 times 7. Okay, again, this part would be 98, and then 98 and 21 is 119, right? And then you need a plus 1 here. Now that does sum up to 120 in base 10. Okay, so what does that mean? And again, y'all, let's just double check here. This is 49. 2 times 49 is 98. 98 plus 21 is 119. And 119 plus 1 is 120. Okay? And so you actually get the answer that we're seeking right here would be 231. 231 in base 7. 231 base 7 equals to 5 factorial. And we've completed the problem. Thank you for viewing.